or go to math.com. Let's click on the calculus button. Click on implicit differentiation, and I believe that's the section we are in. I worked this problem just a minute ago and wrote down the wrong numbers. I wrote down the right numbers on the piece of paper, but then I ended up writing down the wrong numbers on the whiteboard. So we're doing this problem again. 3x squared plus, I got 10,000 more problems to do this year. Got time for that? We need to write this down. Anyway, this is the first of its kind. It says find the equation of the tangent line that passes through the point 5, 3. I better write that down too, or I'll forget it. Whew. 3x squared plus 3y squared is equal to 102, and the point is 5, 3. What is that anyway? That's a half. That's a circle, isn't it? Let's Whoa. What the heck happened? Not exactly sure. Let me draw a picture. Can I do that? Can we draw a picture? This, of course, is actually it's actually a circle, is what this is. And I'm not going to be able to draw a circle, but anyway, this is a circle, and we're at the point 5, 5 with some fixed radius here. We pick, so 5, 5. I don't know, somewhere up here, wherever. I'm just picking a point here. And we're asked to find the tangent, the equation to. So I'm going to say that this is going to be the tangent line, my wonderful drawing here. So as you can see, the tangent line is going to be negative. It's going to be a negative number here. But what we have here is a circle, but this is the part right here at the point 5, 5, and then we're asked to find the equation of this line, which is actually going to be in this form here. Y is equal to mx plus b. Mx plus b. That's what we want to find right there. Okay. Let's go back to blue ink. How's that? So we have 3x squared plus 3y squared is equal to 102. And if you were to multiply through by 1/3 all the way across, you'd have x squared plus y squared. And of course, this would be the radius squared. This number over here, once we divide it through by 3. To find the actual radius, you would square root it, right, to get the actual radius. But anyway, okay, so here's the procedures. Like I said, we want to, it should be stated in the problem, slope-intercept form or something. But the first thing we want to find is m, and m is the slope of the line. And remember what the derivative tells us. The derivative, once we plugged in the x value, it gives us the slope of the tangent line at that point. And that means that we want to find, and instead of y prime, I'm going to say dy over dx here. Okay, so dy over dx in this problem is equal to m, And so that's what we want to find. And of course, we have the point. Oh my gosh, I almost messed this problem up again. This is the point 5, 3, not 5, 5. I think I said 5, 5, 5, 5 or something, but it's 5, 3. I wrote it down on my piece of paper, and that's what it looks like. That's how you make mistakes. Okay, well, let's take the derivative of this. So we have 6x plus, and then this has become 6y times, and I'm going to write, instead of y prime, I'm just going to go ahead and write dy over dx here. And then the derivative of a constant is 0. Now the easy way of doing this is just go ahead and plug in the point 5, 3. So we have 6 times 5 plus 6 times 3, and And then we have dy over dx is equal to 0. So we end up with 30, and actually I'm going to show you something here. Um, so we have 6 times 3. I'm not going to multiply this together, and I'll show you the reason why. Dy over dx is equal to, taking this over, so negative 6 times 5. So we're not going to multiply that together yet. So we have dy over dx is equal to negative 6 times, what the heck? What's going on here? Oh, never mind. I got lost. And then take the 6 times 3 diagonally down. I forgot what the heck I was doing. Okay, well, the reason we did it that way is so you can just look at this and go, oh, those guys cancel out. You know, it's just a whole lot easier to think of it that way when we're reducing it down. Dy over dx is equal to negative 5 thirds. Negative 5 thirds. Isn't that interesting? That's the actual point itself, isn't it? That's funny. Okay, so negative 5 thirds. Now, let's write y is equal to mx plus b. So we write our negative 5 thirds in here for m. And then, of course, our x is 5 plus b, and our y is 3. And so now we want to solve for b in this problem. Solve for b in this problem. So we end up with 3 plus 25 over 3. Right, 5 times 5 is 25. It's a negative, but we're taking it over to the left-hand side of the equals sign. We're left with a b. But remember, this can be rewritten, and we got to get this all in one single fraction. So we have 9 plus 25 over 3, and one more time, this becomes 34. Is that right? 34 over 3, and that is actually going to be our b. That is going to be our b. So y is equal to negative 5 thirds x plus 34 over 3. And that is the equation to the slope of the tangent line. Right? That's the equation to the slope. That's the equation to the line. That's the equation of the tangent line. Oh my God. Negative 5 thirds x plus 34 over 3. Okay, good. This is matching up this time. Anyway, y is equal to negative 5 thirds x plus 34 over 3. Okay, so you want to come on by, say hi, and I might see you there. Practice that, okay?